Hello everyone. Today we are going to look at these notes on experimental and theoretical probability. So we have a couple blanks to fill in at the top. It says that theoretical probability is based on what should occur. An experimental probability is calculated by either performing an experiment, conducting a survey, or looking at the past outcomes of an event. All right, so what I'm going to do is give you a couple minutes to read everything in this box below. So go ahead and hit pause, read that, and then you can continue. All right, so one thing I will just point out is that whenever we're talking about probability, which a couple questions last week may have mentioned probability, but now we're really taking notes on these, it has to be a number between 0 and 1. So for example, if I have a 0.25, that's how it would look in decimal form, but I could also write that as a fraction, 1/4, where it says 1 in 4 here. I could also write it as a percentage, 25%. So any of those are acceptable ways to represent a probability, but just so I don't have to get out a calculator, I'm going to be leaving them as fractions and just make sure that they're reduced. So the star down at the bottom below the box says that when using the word or, we will be adding. So there's some problems today where we'll see or, and we'll use that addition rule from last week. Just to go through 1 through 10 real quick and see how you did with those. When you flip a coin, the probability will come up heads is closest to 0.5 because there's a 50-50 chance, heads or tails, 2 outcomes. The first card you draw from a deck will be a heart. That would be 0.25 because 13 of the 52 cards are hearts. So it's 1/4 of the deck. There's 4 suits. The next baby born in your town will be a girl. So that would also be 50-50, 0.5. There will be a snowstorm in Los Angeles this July. That's probably closest to 0 because it's very unlikely. The next time you roll a die, you'll get an odd number. 1, 3, and 5 are all odd. That's 3 out of 6 outcomes, which is closest to 0.5. You will be assigned math homework next week. Ooh, this is actually a trick question because next week is spring break, so I'm going to go ahead and put 0. But if it was any other week, then it'd probably be guaranteed since I usually give homework every night. So 0 or 1, depending on the week. Number 7, the first card you draw is a face card. There are the jacks, the queens, and the kings. 3 types of face cards out of 13 different types of cards. So that is pretty close to 1/4. Not exact, but it's closest to 0.25. What's probably you will attend school on July 4th? That's 0. Even if you're in summer school, you usually have that day off. The first card you draw from a standard 52 card deck will be a spade, club, or diamond. So like it says down below, we're adding. Spade, club, or diamond is 3 out of the 4 suits. That's closest to 0.75. It's exactly 0.75. And finally, the Chicago Cubs will win the World Series this year. Well, that's kind of an opinion, so I'll just skip that last one. And if you're a Cubs fan, maybe you said a 1 or a 0.75 or 0.5, or maybe you said a 0. So there's no exact answer there. All right, if we look down at example 1 now, we're looking at the word Mississippi, and we want to find probability of selecting the letter M, then S, then a vowel, then S or P, and then a B. When I'm looking for a certain event, like selecting the M, to do this, probability of M, this is the notation I like to use, I want to take the number of M's divided by the total number of letters. So in this case, there's only 1 M. And if we count how many letters are in Mississippi, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our answer is 1/11. Since that can't be reduced, I can just stop there. So I'm not going to show all this work for the next few examples. I'm just going to look at the number of that event divided by the total number. And if the fraction can be reduced, then I will reduce it. Selecting the letter S. Okay, we have to count the S's here. 1, 2, 3, 4. And the total we know is 11. So my answer is, probability of getting an S is 4/11. How about a vowel? We know the vowels are A, E, I, O, U, which in this case, the only vowels are the I's. And the probability of an I, there's 1, 2, 3, 4 I's out of a total of 11 letters. So once again, let me make that 4 look a little nicer. The probability would be 4/11. Now, if we want the probability of an S or a P, we're going to do the probability of an S plus the probability of a P. And then with our addition rule, we know that then we would subtract the overlap, but there's never a letter that's an S and a P at the same time. It's either one or the other. So basically, you would just subtract 0. So I can ignore that part. So we already said that there are 4 S's. So 4/11 is that probability. And it looks like there are 2 P's. And we already have a common denominator. So 4 plus 2 is 6. And our answer is 6/11. Make sure you don't give an answer of just 6. That would be how many letters are S or P. But we're looking for a probability, which remember is between 0 and 1. So 6 is above 1. The answer has to be 6/11. Finally, selecting a B, we look at how many B's there are, and there's 0. And if we divide that by 11, that just becomes a 0. So that's impossible. So remember, the probabilities can be anything between 0 and 1. And if it equals 0, it cannot occur at all. And if it equals 1, it's guaranteed to occur. So in this case, if I said, what's the probability of getting an M or an I or an S or a P, that would be a 1, because that's every outcome. All right, moving on to example 2. When rolling a 6-sided die, find the probability of, so let's just talk about real quick what a 6-sided die looks like. I'm no artist, but here's a cube, and we know on one side we have a 1, another side we have a 2, another side we have a 3, a 4, a 5, and a 6. And a standard die just means it's fair, that each outcome is equally likely. So for the probability of rolling a 3, that's 1 outcome out of 6. Rolling a 7 is impossible, so 0 out of 6, which is 0. Rolling an odd number, the odd numbers are 1, 3, and 5, which is 3 out of the 6 outcomes, and I can reduce that to 1/2. Rolling a prime number, so what does prime mean? Prime numbers are numbers that can only divide by 1 and itself. Those are the only factors. So 2 is actually the lowest prime number. Its only factors are 1 and 2. 3 is a prime number. 5 is a prime number. And after that, it would be 7, 11, 13, 17. Notice I skipped 9 because it can divide by 3. And notice I skipped 15 because it can also divide by 3 and 5. So all we really need is the numbers on the die, which would be 2, 3, and 5. So that's 3 outcomes out of 6, which reduces to 1/2. Next, we have rolling an even number or a 3. So to find the probability of an even or a 3, I'm going to take the probability of even plus the probability of 3 minus the probability of both even and 3. Once again, this is our addition rule from last week, where I said it can work with numbers and with probabilities. So now we're doing it with probabilities. So even is 2, 4, 6. There's 3 out of 6 outcomes there. The probability of a 3 is 1 out of 6 outcomes. And then how many of the outcomes are even and 3? None of them. There's no overlap there because 3 is not even. So I can just subtract 0 out of 6. Or I could forget that part completely again, because these events are disjoint or mutually exclusive. So 3, 6 plus 1, 6 is 4, 6, which is equal to 2/3. The last one is rolling a multiple of 3 or a multiple of 2. So let's talk about what the multiples of 3 are and what the multiples of 2 are. All right, a multiple of 3 would be 1, 3, and then I'm sorry, multiples of 3 do not include 1. I was thinking of factors for a second. Multiples of 3 would be 3 and 6. Multiples of 2 would be 2. If I add 2 to that, I get 4. If I add 2 again to that, I get a 6. Okay, so those are the multiples of 3 and the multiples of 2. So if I want the probability of getting a multiple of 3 or a multiple of 2, I'm going to find the probability of multiple of 3 plus the probability I have a multiple of 2 minus the probability of a multiple of 3 and a multiple of 2 using the addition rule. A multiple of 3 is a 3 and a 6, so there's 2 out of 6 outcomes. The probability of getting a multiple of 2, there's 3 outcomes. See above, 2, 4, and 6 out of 6. But the question now is, did I count any outcomes twice? And the number 6 was double counted because 6 was a multiple of 3 and 2. So because I double counted that, and that's the probability of both multiple of 3 and multiple of 2, I'm now subtracting the probability of a 6, which is 1 out of 6. So when I add 2 out of 6 plus 3 out of 6, this gives me a 5 out of 6. But then I minus 1 out of 6. So that is equal to, I'm going to write it over here, 4 out of 6. And that can reduce to 2/3. So we said in part E, these events, an even and a 3, are disjoint or mutually exclusive, where in F they are not. So if I drew a Venn diagram, disjoint would look like this. There's no overlap, there's nothing in common, which is why I subtracted 0. But here, if I list all the multiples of 3 and all the multiples of 2, the number 6 overlapped and was in both of those circles, which is why I had to subtract the probability of a 6. All right, it looks like we have 3 more examples to go here. So if we take a look at example 3, it says that L flips a penny 83 times. The results are shown in the table. All right, we want to know theoretical probability and experimental probability of certain outcomes. Experimental is where we're looking at this table. Theoretical is where we're just thinking, theoretically, if I flip a coin, what would I expect to happen? So the probability of getting heads, theoretically, is 1/2, or 0.5, or 50%, okay? Now experimental means in this trial of 83 flips, how many times did I get heads? So to get the probability, I'm going to take the number of heads, 38, divided by the total number of flips, which was 83. And I don't think that will reduce at all, so there's my answer. I'm just going to leave it as a fraction. For theoretical probability of getting tails, just like part A, that's 0.5 or 1/2. But the experimental probability is the number of tails in this experiment divided by the total number of flips. We had 45 tails divided by 83 flips. So there's our answer to part D. So I know the heading of our notes was experimental and theoretical probability. And with this example, you can see the difference. Theoretical is if I were to take a fair coin right now and flip it, what would I expect to happen? Experimental is I flipped it and this is what happened, so I'm just basing it off of the results of the experiment. All right, let's see what example 4 says. It says that 28 algebra kids take the Unit 7 test. 4 earned an A, 6 earned a B, 8 earned a C, and 5 earned a D. The rest earned an F. So I made a little table here as I read the problem. Now it says the rest. It didn't give us a number, but we did have our total was 28. So if I add these, I have 10, 18, 23. So 28 minus 23 is 5. So the rest would be 5. Part A says, what is the probability that a selected student earned an A? So if I want the probability of this event, A, I can take the number of A's divided by the total. So there's 4 A's divided by 28 students in the class. And because 28 can divide by 4 7 times, this can reduce to 1/7. Part B, what is the probability that a student earns an A or a B? So I'm going to take the probability of A plus the probability of B minus the probability of both A and B. Well, you can't get an A and B in a class, so that's going to be 0. So really I'm just adding the probability of A and B together. So for A, it's 4 out of 28, which I found above, and then the probability of a B is 6 out of 28, because 6 students in the class got a B out of all 28. So if I add these with my common denominator of 28, 4 plus 6 is 10. And these are both even numbers, so if I divide by 2 on the top and on the bottom, this reduces to 5/14. Part C, what is the probability the student earns at least a C? What does at least mean? It means a C or higher, which in this case would be or better, meaning an A, B, or a C. So if I add A and B, which I already did up above, and then add C to that as well, we have now a 4 over 28 plus a 6 over 28 plus the probability of a C is an 8 over 28, and that total is 18 over 28. And 18 over 28, once again, these numbers are both even. If I divide the top and the bottom both by 2, I get 9/14. Last question, what is the probability a selected student did not pass the test? If you do not pass, you get an F. What's the probability of an F? So we had found this number was 5 out of 28. The number 5 we found earlier by figuring out how many students were left. So our probability is to take 5 out of 28. So once again, when we're finding probabilities, every single answer on this page is a number between 0 and 1. All right, last example. 30 students are polled about whether they like the Bulls or the Blackhawks. 20 students like the Bulls, 15 like the Blackhawks, 11 like both. How many students like the Bulls or the Blackhawks? This is not even asking for a probability. So this is all review of last week when we did the addition rule and when we did Venn diagrams. So I'm basically just looking for the number of students who like the Bulls or the Blackhawks. I'm going to use H for Blackhawks, for Hawks. So I'm going to take the number that like the Bulls plus the number that like the Hawks minus the number that like both Bulls and Hawks. So 30 are polled, 20 like the Bulls, so this is 20, 15 like the Hawks, and 11 like both. So 20 plus 15 is 35, and 35 minus 11 is 24 students. Now, I'm going to talk about a couple more things relating to this problem. If I had said, instead of how many students, what is the probability a student likes the Bulls or the Hawks, I would basically have all the same work, except with the 20 plus 15 minus 11. It would all be out of 30, out of 30, out of 30. And my answer of 24 would be out of 30. So because it's a probability, now I get an answer between 0 and 1, and I'd be able to reduce that fraction. They're not only even, but both numbers divide by 6, so I would get 4/5. One more thing is that you could have done this problem also with a picture. Bulls, Hawks, 11 like both. Bulls was 20, so this whole circle has to add to 20. If there's 11, then this is a 9. Hawks was 15. This entire circle has to add to 15, so 11 plus 4 is 15. And since this adds to 24, I know 6 would go out here, since there's a total of 30 students. And then if I want the probability of, or not the probability, but the number of students that like Bulls or Hawks, that's the union of these two events, which is basically adding 9 and 11 and 4 together, which would also give me a 24 like I got above. So that's the other way you could have done this problem. So from now on, pay attention to whether problems will ask you for the number of students or the probability of students. All right, that concludes the notes for today. So go ahead now and try doing the homework. All right. Have a good day. Bye.